We're going to talk about your data, and we're going to focus on our 2 learning topics for today. So I've got some data that I collected 5th period that I'm going to have up on my screen. You should use your collected data, okay? First thing I want to know is how many variables were we just working with? 2. What were those 2 variables? Number of rubber bands and distance traveled. Which one would be the explanatory variable? Number of rubber bands. And so then the response variable would be distance traveled. The explanatory variable gets used to predict. This is our input. And the response variable will be the outcome or the output. Explanatory variable, number of rubber bands, distance traveled is the response variable. And if you think about this in the context that I set up at the beginning, that we're going to be sending Barbie bungee jumping off of the balcony, we won't know how far she travels until we actually do this. We're going to try to use the number of rubber bands to predict how far she's going to go. Do you think it'll take more than 7 rubber bands to give her an exciting flight off the balcony? Yeah, probably quite a few more. We're going to build some tools to come up with how we will predict the number of rubber bands throughout the course of this chapter. All right, next thing we want to do is take our individual data, so what you collected with your group, and we're going to make a scatter plot of this. So what are we going to graph along the x-axis? Number of rubber bands. And we said that that was which variable? That's our explanatory variable. The explanatory variable always goes on the x-axis. And then we've got what on the y-axis? Distance traveled, which is our response variable. Again, that's always going to go on the y-axis. They've already got the numbers on the x-axis for us. Does it make sense that they're counting by ones along the x-axis? Yeah. They didn't fill in the y-axis for us, though. Would it make sense to count by ones along the y-axis? Give me something that we could count by. We could count by tens. Could you count by 5s? Make sure that you have enough room to fit all of the data from your group if you count by 5s. I'm going to go ahead and count by 10s up here. Right. Kind of a side note before we go any further here. When you're making a scatter plot, if the y-axis doesn't start at 0, if the y-axis doesn't start at 0, say I was measuring something else and my data doesn't really start until I get to 100. but then I need to count by tens after that so that I can see my data. If we don't start it at 0, you're going to put like a squiggle here. It's like a back and forth like this to show that you've left out some vertical space here. And now I want you to take your group's data with number of rubber bands being on the x-axis and distance traveled on the y-axis, and I want you to plot these points, Algebra 1 style. So please go ahead and plot those 7 points. I'm going to plot mine up here. I want you to plot yours for your group on your graph. So with my data, 0 rubber bands, she came in at about 26 centimeters. So I'm going to put a dot at 0.26. You put your dot wherever your data indicates. For 1 rubber band, I had 36 centimeters, and so on and so forth. Your graph is going to look different than mine, but it should have generally the same overall shape or feel to it. Does your graph look somewhat similar to mine? How would you describe the overall shape or the overall form? What does this look like? What'd you say? Looks like a line, right? I could grab a straight edge and it wouldn't go through all the dots, but I could hit quite a few of them with a line, and the others would be really close to it. So yours should have a somewhat linear appearance to it. Yep, yours looks pretty good. I want to describe this scatter plot. Do you guys remember how we used socks to describe distributions when we had just one variable? We're going to use another acronym to help us describe a distribution when we have a scatter plot. 2 variables. These 2 variables are what type? Categorical or quantitative? Quantitative. We measured number of rubber bands with a numerical value. We measured distance traveled with a numerical value. All right, so the acronym that we're going to use is DUFS. Anybody watch Simpsons? You said it, not me. If it helps you remember it. So we have SOCs for distributions with 1 variable, DUFs for distributions with 2 quantitative variables. The D stands for direction. Yes, sir. Oh, down at the bottom, it's a plus sign. We'll get to that in just a second. I know it does look like a T, but it's not. I'm covering up the rest of it. So the first one we do is direction, positive or negative. Every now and then, we will run into a distribution where we're like, it's not positive or negative. But that is very rare. So we generally want to steer clear from saying that there is no direction, positive or negative. When you look at our scatter plot, yours on your paper, mine on my board, how would you describe the overall direction of this? Positive. Why? Because it goes up. As we go from left to right, the dots go up, just like slope in Algebra 1. What would a negative direction look like? Goes the other way. Starts high and then ends low down as you move to the right. All right, so I'm going to start my description of this scatter plot by saying there is a positive All right, and I'm jumping around. I'm not doing Duff's in order. Strength. Strong, moderate, or weak. We decide whether it's strong, moderate, or weak based on how closely it matches the form, which is what my F stands for. For the most part, we're going to describe our form as either linear or nonlinear. If you look at a scatter plot and it has a very obvious U shape to it, like a parabola, then I would name it by that. If it has a very obvious like J shape or curve to it, then I might call it an exponential. But 99% of the time, we're going to describe this as linear or nonlinear. And of those, at least 95% of the time, we're going to call it linear. The more closely the scatter plot matches the form that we have described, the stronger it is. How would you describe the strength of our scatter plot? Strong. It had a very linear appearance to it. So I'm going to say that there is a positive, strong, linear relationship I only have the lines because I'm a messy writer. There's a strong positive linear relationship, and now I'm going to get my context in here, between, and we're going to name our variables here. What were the variables again? Number of rubber bands and distance traveled. And I'm going to put my units for distance traveled. We measured those in centimeters. There's a positive, strong, linear relationship between number of rubber bands and distance traveled. I've got direction, I've got strength, I've got form, I've got context. We still have this one piece that we haven't talked about yet. The U stands for unusual features, like outliers, or strange clusters of data. So I'll come right back to this, but I want to look at my scatter plot for a moment. As I look at the scatter plot, are there any of these points that you look at and you're like, what are you doing? How'd you get way far away from everybody else? No. So my scatter plot has no unusual features on it. If there is a dot that's way out of place, or something that you might look at as being an outlier, we're going to mention it here. Or if there's a strong cluster of data that is far away from the rest of it. It doesn't have to just be one point. So for this one, I'm going to say there are no unusual features. And now we've covered everything that we needed to with Duff's. Just like with socks, you don't have to do it in the order of the letters. We just have it because this helps me remember all four pieces. So we turn it into a word. So far, so good? All right. We've hit our two big learning targets for today. The two things that we were focused on was how to create a scatter plot from data. Explanatory variable has to go on the x-axis. Response variable has to go on the y-axis. And then describing that scatter plot. So Duff's plus context, direction, positive, negative, none. Please be very, very careful about the none. We use this so rarely that I don't even include it when I'm talking about it. Tomorrow, we'll look at what a scatter plot looks like when there's the different directions and different strengths. Unusual features, outliers or clusters, form, for the most part, we're looking at linear or nonlinear. And again, like 99% of the time, we're going to describe this as a linear relationship because no other shape actually fits it. And then strength, how closely do we meet this linear form? I would like to give you guys about 5 minutes to do parts A and B in the Check Your Understanding. I want you to identify the explanatory and response variables from the table and the scatter plot, and then I want you to describe the scatter plot using Duff's. Yes, absolutely. This guy? You're welcome.
Identify any possible direction that we can. If you don't think there's much direction, then you'll probably say that it's weak when we talk about the strength. But look for a pattern. At the beginning, when you're on the left, do the points start high or low? As you move to the right, do the points get higher or lower generally as you're looking at those? So when you're trying to determine positive or negative, you want to look, start over on the left of the graph. Where are the points at, high or low? Yeah, like right here on the x-axis, are the points high or low? They're high. And as you move over, did the point go higher or did it come down? Went down. As you continue to move this way, do the points go higher or lower? Lower. Then we jump back up again here, and then it goes down, down, down. Yeah. But each time it has this kind of thing going on, right? And when it jumps back up, it never jumps back up as high as this. So how would you describe that? Do you think that's a positive or a negative direction? Then write that down.
Oh, for the line at the corner. So I just put no linear.
So we're going to put this, and I'll explain why. Okay?
Is it because you can form a line?
Kind of, yeah. Like if I put a line in there, I'm going to hit a lot of those points, right? I don't hit all of them, but I hit a good chunk of them. Yes.
All right. What are the explanatory and response variables? Start with explanatory. What is the explanatory variable here? Screen time. And response variable? Rank. Why? Why did you pick screen time as the explanatory and popularity rank as the response? What did you say? Oh, this is on the x-axis. Fair enough. What if the scatter plot hadn't been there? What kind of reasoning or justification could we use? Yes?
Like the more screen time a character has, the more time you have to get to know them.
Absolutely. Yeah. So the more exposure that you have to that character, the more they grow on you over time. So if I know how much screen time a character has, I could use that to make a reasonable prediction about where they fall in the rankings, right? So we would be using the explanatory variable, using screen time, to explain or to predict what the ranking is. All right, now let's describe this distribution. How would you describe the overall direction of this scatter plot? Negative. We start high on the left. On the right, the points are generally lower than they were on the left side. So we have, sorry, I uncovered the wrong one, negative. I would describe it as weak also. It doesn't look as much like a line as our Barbie doll data did. But I'm still going to refer to this as a linear relationship because a line fits this data better than any other shape I know of. And if I were to draw in a line right here, I'm going to be really close to a majority of those dots. There's some down here that are a little weird. There's some up here that are a little weird. But overall, a line of best fit is going to be pretty close to the majority of those dots. And then we got to get our context in here. So between what and what? Between screen time and rank, or rank and screen time. Darth Vader. What was Darth Vader's ranking? 1. He is the most popular. How much screen time did he have? 150 minutes. That's way down here. We said that there was a negative relationship with this, that the more screen time you had, the higher your ranking, and the less screen time you had, the lower your ranking, with 1 being the highest ranking and whatever, 14 being the lowest ranking. He kind of stands out to me. Because if I try to use this pattern of more screen time means a better ranking, he doesn't fit that pattern at all. So I would probably describe that as an unusual feature here. He's a potential outlier. We will formalize some of these ideas more as we go on over the next couple days. I'm fairly certain that nobody saw the reading assignment that was up on the board yesterday, and I didn't mention it, so if you didn't do it, that's fine. But I would like you to do some reading to be ready for tomorrow, pages 152 to 169. 152 to 169 for the reading. The homework that you guys grabbed on your way in the door is due on Tuesday, which is the first day after the weekend. We don't come to school on Monday. So the first day after the weekend is when your homework is due. Anything on the homework that refers to R or R squared, you can't do yet. We haven't talked about that. We haven't learned that. We're going to do that tomorrow. All right? So do the reading tonight. If you want to get started on the homework, you can make scatter plots. You can describe distributions using duffs. R and R squared stuff will wait.